Now we consider a couple of useful techniques for finding limits, some algebra that can be used to simplify the calculation of the limit. The first of these techniques is factorization, and here's an example of it. We want the limit as x goes to 1 of x cubed minus x squared over x minus 1. We are tempted to use our rule that the limit of the quotient is the quotient of the limits, if provided that the individual limits exist and the denominator is not going to go to 0. But in this case, the denominator will go to 0, so we cannot use that. Okay. Well, another possibility is to use factorization. So if I factor out x squared from x cubed minus x squared, I get x squared times x minus 1 over x minus 1. Now I can cancel, provided that I'm not dividing by 0 anywhere. And I'm not, because I'm saying the limit as x goes to 1 means as x gets arbitrarily close to 1, but is never actually equal to 1. And so that denominator is never actually 0. I can cancel x minus 1 by x minus 1. And so now I need to evaluate the limit as x goes to 1 of x squared. Well, that will be 1 times 1 from previous results, which will equal 1. So sometimes you can use factorization, and then you can get common factors on the top and the bottom, which can then cancel, leaving you with something that can be evaluated. Okay. There's a similar technique, and that is if you've got a square root in your problem, it can be helpful. In this case, limit as x goes to 4 of root of x minus 2 over x minus 4. Again, if you just tried, well, the limit of the quotients is the quotient of the limits, that does not work here because your denominator function is going to 0. Okay, so you need to do some sort of a manipulation, and what we do here is we can get rid of the square root sign by multiplying root of x minus 2 by its conjugate root of x plus 2. Now, if you multiply on the top, then you also have to multiply on the bottom by the same thing. Again, be careful that you're not multiplying anywhere by 0. So we multiply on the top and the bottom by root of x plus 2. And on the top, we get x minus 4. And on the bottom, we have x minus 4 times root of x plus 2. Now we can cancel out the x minus 4 factors on the top and the bottom, and I have the limit as x goes to 4 of 1 over root of x plus 2. Well, as x goes to 4, the root of x gets very, very close to 2, so I end up with, this is going to get very, very close to 1 over 2 plus 2, which is 1 over 4. Okay, so two algebraic techniques that you can use to rewrite the limit into some form that will allow you to do some simplifications and then allow you to do the limit.